fundamental theorem of arithmetic. The basic idea is that any integer above 1 is either a prime number or can be made by multiplying prime numbers together. Like this. This continues on. 10 is 2 times 5. 11 is prime. 12 is 2 times 2 times 3, and so on. So they are either prime or primes multiplied together. The fundamental theorem of arithmetic. Let us start with the definition. Any integer greater than 1 is either a prime number or can be written as a unique product of prime numbers, ignoring the order. What does it mean? Let's build up the ideas piece by piece. Any integer greater than 1 means the numbers 2, 3, and so on. A prime number is a whole number above 1 that cannot be made by multiplying other whole numbers. The first few prime numbers are 2, 3, 5, 7, and more. Product of prime numbers means that we multiply prime numbers together. Example, is 42 prime, or can we make it by multiplying only prime numbers? Let's see. 2 times 3 times 7 equals 42. Yes. 2, 3, and 7 are prime numbers, and when multiplied together, they make 42. Try some other examples for yourself. How about 30 or 33? Think of prime numbers as the basic building blocks of all numbers. Unique product of prime numbers means there is only one unique set of prime numbers that will work. Example. We just showed that 42 is made by the prime numbers 2, 3, and 7. No other prime numbers will work. We could try 2 times, 3 times 5, or 5 times 11, but none of them will work. Only 2, 3, and 7 make 42. We may have to repeat a prime number. Example, 12 is made by multiplying the prime numbers 2, 2, and 3 together. That is okay. In fact, we can write it like this, using exponents. 12 equals 2 squared times 3. Note, 4 times 3 is not right, as 4 is not a prime number. A factor tree can help us find the prime factors of a number. We start with our number, then break it into any of its factors. If a factor is not prime, we keep breaking it down until only primes are left. Example. Let's break 48 into 2 factors. 48 equals 8 times 6. No primes yet. Let's continue breaking them into smaller parts. And 4 can still be broken into 2 times 2. Now we have all primes. And here is our factor tree. And no matter which factors we start with, we always end up with the same set of prime numbers. Let's try starting with 48 equals 4 times 12 instead. We still end up with the same primes. This shows the fundamental theorem of arithmetic in action. The numbers may branch out in different ways, but we always reach the same unique prime factors in the end. So there you have it. Any of the numbers 2, 3, 4, and so on are either prime numbers or can be made by multiplying prime numbers together. And there is only one unique set of prime numbers that works in each case. Here are some more examples. At the top I said, ignoring the order. By that I mean 2 times 11 equals 22 is the same as 11 times 2 equals 22. So don't just rearrange the numbers and say, it isn't unique, okay? Here are the first few numbers and their prime factors. Why not continue this list to 100 yourself? Summary. The fundamental theorem of arithmetic is like a guarantee that any integer greater than 1 is either prime or can be made by multiplying primes. And there is only one way to do that in each case. You can visit us at mathisfun.com.